Now let's see how the PKCE flow addresses the security challenge of the authorization code flow that we covered in the last lesson. Once again, we have the same malicious application, an interceptor that's capable of monitoring and intercepting browser or network traffic. This time, the user agent is, for example, a browser, and the client is a single page application, configured as a public client in the authorization server. In the PKCE flow, the client has already generated a proof key for code exchange and securely stored the code verifier locally. The authorization server during the initial redirect request has stored the code challenge and the code challenge method. Now, when the authorization server redirects the resource owner back to the client via the user agent and provides an authorization code, the malicious application intercepts again because it's still monitoring the traffic. Then, the malicious application attempts to exchange the intercepted code by sending a post request for an access token. The authorization server will validate the authorization code, and the PKCE code verifier, I don't know, since the code verifier doesn't match the stored code challenge, the request will fail, resulting in an unauthorized response, leaving the hacker very sad. On the other hand, the legitimate client sends the correct post request with the authorization code and the valid code verifier, I know it. And there we go, the authorization server successfully validates the request and grants the client an access token. Now let's assume the malicious application tries to intercept the code verifier when the client sends it to the authorization server. That wouldn't work either, because the client sends the code verifier via a post request, which is typically encrypted with SSL TLS, once again leaving the hacker very sad. This additional layer of security, the requirement for the code verifier, prevents unauthorized access and solves the security challenge of the authorization code flow for public clients. Even though the PKCE flow was originally designed to address a security challenge for public clients, it is recommended for both public clients and confidential clients. PKCE was originally designed to protect the authorization code flow in mobile applications, but its ability to prevent authorization code injection makes it useful for every type of OAuth client, even web applications that use a client secret. With the code and the PKCE mechanism, this flow ensures security for both public clients and confidential clients, providing a critical layer of protection for public clients and enhancing security for confidential clients as well.